today's lesson is the very first day of officially introducing what? What we call trigonometric, or just trig. No one says trigonometric, okay, or trigonometry. Everyone says trig, trig, trig. You just say the first four letters, okay? And we will be dealing with this very famous phrase that will stay with you grade 11 and 12. It's called SO, or SOH-CAH-TOA, okay? So the whole point of this lesson and tomorrow's lesson and pretty much the next 4 or 5 days is to make sure that we are able to do what? To find angles without using a protractor. So you might ask why I give you a protractor today. Not because we want to solve, just because I want to show you that what we do is actually 100% correct, okay, just to check. And the second thing, same thing, finding length of sides, like how long each side is, without the use of a ruler, okay? All right, so in any right triangle, what's an acute angle? Actually, in any triangle, what is an acute angle? It's an angle less than, Haley? Any angle, not less than or equal. No, exactly less than 90 degrees is called a what? It's called an acute angle, okay? So we're going to put 90 degree here. 90 degree, okay? Has three special ratios or fractions associated with it, okay, or linked to it, which are the exact same three that we did yesterday, okay? The table yesterday from yesterday's note is exactly what this is, okay? All right, so everyone, before we do that, let's look at this triangle. What kind of a triangle is this? A right triangle. Actually, what do I have to put inside of it to indicate it is indeed a 90 degree, a right triangle? Perfect. I have to put the square or the box. So everyone go ahead. Put yeah, I know. Put the box or the square. Okay. Now, how many acute angles do you always have in any right triangle? How many acute angles? No, not right angles. How many acute angles do you have in any right triangle? Two. Either this one, no matter how you spin it, how you flip it, it doesn't matter. You have yourself 190 degree, which means this one is acute, has to be less than 90, and which means this one is also acute, okay? So why did I write angle there? Because whenever you have a right angle triangle and you want to apply, everyone, you want to apply trigonometry or SOH-CAH-TOA, you have got to choose one of the two acute angles. You cannot just do it without choosing. You always have to indicate to me which acute angle you're focusing on. By the way, sometimes you have complete freedom to choose this one or this one, which means you choose. Sometimes I tell you which one to use, okay? It's 50-50. Half the time I tell you which one to choose, half the time you choose, okay? So today, let's actually focus on this one. So I want you just to circle it a little bit. Don't make a big circle. Just circle the word angle. Just to indicate this is the angle we're going to focus on. Okay. We have to introduce three new words, actually two new words, just like the words we introduced yesterday. First of all, where's the hypotenuse of this triangle? By the way, good news with everyone. Good news with trigonometry. You do not have to label capital A, capital B, capital C. Like you do not have to do the same stuff we did with similar triangles, okay? But you have to label the sides though. Which one of those is the hypotenuse? We should not have any discrepancy or any disagreement. Patrick, which one? Exactly. So, oh, hold on, my bad. Just 1 second. It's back. I know, but I'm afraid it might keep doing that. So I just want to. Okay, hopefully it doesn't. All right. Patrick, which one? The side opposite to the what? Or the longest side. Both properties are for it. So everyone go ahead and let's label that one height. So H. Hello, Mr. Baban. Thank you.
Are those to be handed out?
Absolutely. Thank you. I'll remember. Thanks. So this one is height. Okay. Now, what two new words did we learn yesterday? If you look at your notes from yesterday in the table, we did not just use the word hypotenuse. We also used two new words. What? Say again. Opposite and adjacent. The easiest one to always pin first is the opposite. Why? Because what does opposite mean? Next to you or across from you? Exactly. Opposite, adjacent. So whatever is in front of the angle is the opposite. So according to this angle, if you walk away from it, this is your opposite. Everyone, remember, I think it was Faisal who said yesterday, isn't this angle the opposite? Opposite, adjacent, and hypotenuse are not names of angles. They're names of what? Sides or length, exactly. So this is not opposite to that. This side is opposite to that. Perfect. So go ahead and just write. What's the symbol for opposite? OPP. It's always three letters. Perfect. OPP. That only leaves one thing, which is what? Adjacent, which means adjacent is the one that's neither this one nor this one. So A, D, J. Check. So far, so good? Okay, so the first step is to indicate what? Which what? Come on. You have got to tell me which angle you're using. Because, okay, why do you think you have to tell me which angle you're using? Let's flip it. Let's say you did not use this angle. Let's say for some reason, which could be 100% correct, you wanted to focus on this angle. Does that change the labeling of this one? Haley, how so? Okay, before you say that, which one of those three never changes no matter which angle you look at? Hypotenuse. Hypotenuse is the one opposite to the 90 no matter what. Tell me how things change then. Exactly. If you're standing here, this would be your opposite. This one is in your face. And this would be your what? Which it completely changes what? Every single calculation you do from then on, which means you always have to tell me which angle you're looking at first. Okay, so we get that out of the way, and you label. Now, we said there are three important ratios, which is just fancy name for fraction, that are what? That are associated with this angle. Everyone, if you divide the opposite over hypotenuse, how do you write it? You just write OPP, go ahead. OPP over HYP. OPP over HYP. Okay? All right. This ratio in math since the days of the Greeks, this has been going on. By the way, this is one of the most important inventions of the human mind. The Pythagorean theorem was one thing, and this idea of right triangles having special numbers for the angles is insanely important. Every building, every technology you have is due to that, okay? In part. It's called, who can read this word? Okay, if you take out only three, what can you say? Okay, but if you put this, it looks like what? Mine, right? So this word is what? Sine. Here's the thing. We abbreviate only taking the first what? Three. And by the way, usually we use what? Small letters. But I've seen people say S-I-N, and I've seen people say S-I-N. I have a habit of using what? Small letters. Okay, so I'm going to start doing that from now on. Although you might find textbook with capital letters. S-I-N. Okay. Important, everyone. I know it looks like the word what? No. This one looks like the word what? Sin. Never say sin. Always say the original one, which is what? Sine. So even if you see this, always say what? Sine. Okay. Always say the full word. Sine. Even if you see S-I-N only. Okay. So if you ever divide opposite by hypotenuse, you get the sine. Okay. Let's go to the next one. Again, I will explain what all this means at the end of this paper, and then on the flip side. What if you divide adjacent over hypotenuse? What's the short form of adjacent? No. The short form of just adjacent. ADJ. Yep. So go ahead. ADJ. And hypotenuse is still what? HYP. Okay. Same thing. We never use the full word. We say it though, but we never use it. So we basically just write what? COS. So again, I use lowercase letters. By the way, some people even use lowercase letters for this, like small a, small d. It doesn't matter. Just write something that looks like this. So COS. And we still pronounce it what? Co. Exactly. So always remember, they sound the same. Sine and what? Cosine. Sine and cosine. They're like twins. Okay? So that takes care of what? That takes care of two ratios or two fractions. Okay. The last one is not dividing opposite by hypotenuse or adjacent by hypotenuse. Is dividing what? Opposite by. So which one is missing from these two that was here? This one does not care about what? Exactly. This is the only one. This one is the only one that's missing the hypotenuse on purpose. It was designed that way. So how do you write it? You write OPP, sorry, OPP over ADJ. Okay? Who can read this word? Tangent or tangent. And what's the abbreviation for it? TAN. Tan. Thank you. TAN. Oh, it doesn't. I just have a habit. I just have a habit. When I write edge, opposite, and hypotenuse, I like to write them what? Capital. But when I write the names of the actual things we're going to use, sine, cosine, and tan, I like to write them what? Small. That's all. Again, it's my preference. Feel free to write them all capital or all small. It doesn't matter. Okay? Now, listen up, where did the phrase SOH-CAH-TOA come from? Literally from here. Think about it. What does this one start with? S. And it's what over what? O over H. How about this one? This one starts with what? C. And what is it as an equation? A over H. What does this one start with? T. And what's the fraction for it? O over A. That's why it's called SOH-CAH-TOA. So SOH. Basically, the word so tells you that S sine is equal to opposite over hypotenuse. It's just a way to quickly remember it. So let me show you an interesting way to write it in that. Yeah, you have that little banner. So I want you to write SOH dash CAH dash TOA. Okay, I hope there's enough space. Now, what I want you to do, if you can, is to do this. I'm gonna zoom in so much, so tell you exactly how to do it. On the S, just write sine. On the O, just write opposite, OPP. And the H, just write hype. And by the way, what am I using in all of them? I'm using now lowercase. You see, it doesn't really matter. It's just a way to write the words. Okay, how about the C? What does it stand for? C. Cosine or cos, yeah, so COS. How about the A? ADJ. And how about the H again? HYP. Finally, T is tan, O is OPP, and A is ADJ. Sorry, it went into the triangle, but you know. And that's why SOH-CAH-TOA is a quick way to remember which one is defined in terms of which two. The sine is defined in terms of opposite and hypotenuse. The cosine is defined in terms of adjacent and hypotenuse. The tan is defined into what? The terms of, opposite and adjacent. Okay, so now I want you to actually what? Everyone, I want you to do the following. I'll give you rulers. I want you to measure the sides of this triangle, just the sides. I know I give you a protractor. Do not bother with the protractors now. So if you have your ruler, go ahead. You can start measuring. So go ahead. Okay, who's got numbers? Come on. Okay, Amr, which one are you going to give me? Because you can give me any one of the three. Come on. Okay, what did you get for the opposite? Because I want to check with others as well. 5 point? So Amr got 5.5 for the opposite. How many people? 5.5? Do we agree? 5.4. Okay, how many people got 5.5? How many people got 5.4? Okay. You know what? Let's take an average. What's the average between 5.5 and 5.4? 5.45. Okay. Again, that's the point of what? Of learning all this. This is the last time we're gonna use rulers. See, we don't have to discuss, who's right and who's less right and who's less wrong. Okay. So everyone, let's put on the opposite. Put 5.45 centimeters. Go ahead. I'm gonna use black. 5.45 centimeters. Okay. Who's got another one for me? We have two more sides. Rauda, which one? The adjacent. What did you get? Say again? Uh, sorry. Rauda got 4.4 for the adjacent, for the short side on the ground. 4.4. Anyone else? Come on, people. Tell me if you agree or if you have a slightly different measurement. 4.4? 4.4? Okay, it seems that most people are okay with 4.4. So go ahead and on top of the word adjacent, put 4.4. Who's got the hypotenuse? By the way, is there a way to know the hypotenuse without asking you? Think quiz number one. What kind of a triangle do we have? If you know two sides, can you know the third side? Yeah, I can apply what? Pythagorean. But I want to leave it completely to measurement. So who's got the hypotenuse? Hamad, what'd you get? Is enough? How much? 7, almost like perfect. Who's got 7? 7. Wow, okay. That's almost unanimous. All right, 7. Okay. Okay, everyone. What I want you to do now is just measure that angle for me. Come on. Just measure that angle. This one. This one. Right here. Just measure it to the best of your ability. My guess, 60 something. Definitely bigger than 45 degrees. Okay, measure it to the best of your ability. Actually, I'll measure too. Yes. Okay, how can you measure an angle? I'll show you here. Everyone, you hold the angle this way, and right the central part, you put it right here. Make sense? So you put it right here. Look, I'll show you on mine. Yes. But try to put it perfectly. Like right here. Yeah, sure. I have no idea what it is. Yeah. Yeah, it's how many people are getting 51, 52? 51? How many people say 51? How many people say 52? What's the average? What's between 51 and 52? 51 and a half, right there. So let's say what? I mean, by the way, when we do the numbers, it's going to barely make a difference. But you know what? Let's say I want to take everyone into account. So everyone go ahead and write 51.5 degrees right here. Okay. What I want to do now is something you do not need to write. I'm going to open Microsoft, sorry, like Paint, and I'm going to run some calculations here. Okay, everyone. I want you, oops, my bad. Do not write this down. Okay. Everyone, eyes on the screen. What was the first ratio we learned today? It was what over what? No. Yeah, okay. Aside from the name, what was the fraction? What over what? Come on. Opposite over. Okay, sorry. So opposite over hypotenuse. According to these numbers, what's my opposite? Come on. What's my opposite? 5.45. By the way, do not bother with units. Uh, Okay, never bother with units with me in the intermediate steps. If you need to put a unit, put it where? At the what? And the end, final answer. What's my hypotenuse? 7. Okay, let's divide that. I have my machine ready for me. So 5.45 divided by 7. We're ready? You know what? Let's take 3 numbers. Everyone, if I want 3 numbers here, what's my if I want 3 numbers, what's my final number? Is it 778 or 779? 779. So let's write point. Again, none of this you have to write. Okay, let's do the other one. Adjacent over what? Hypotenuse. What's my adjacent? 4.4. What's my hypotenuse still? 7. All right, yet another calculation. 4.4 divided by 7. Okay, let's cut it at 3. What would this be? 629. Thank you. So 0.629. Finally, my opposite over adjacent. What is it? Opposite from here is 5.45. And this one is what? 4.4. I know this got to be 1 point something. I'm not sure. So 5.45 divided by 4.4. Okay, again, cut it at 3. My bad. 1.239 because the 6 bumps up. 1.239. Are we good so far? Okay, everyone, check this out. Pencils down. Look what I'm going to do right now. Seriously, this is the whole point of this lesson. I just want to make sure you can see the whole thing next to each other. There we go. Okay, everyone, pencils down. Let this sink in. What was my angle? What was my angle that I said we're going to work with? What was the angle? 51.5. All right, let's put them up next to each other. What was the thing that was opposite over hypotenuse? Was it sine, cosine, or tan? Was it sine, cosine, or tan? Which one is opposite over hypotenuse? Sine. Never say sin. Say sine. Okay? Sine. Check this out. Everyone, look, I'm going to clear everything. Look at this. What's my angle again? 51.5. Trigonometry. Which one of those am I going to choose? This one, or this one, or this one? I'm going to choose the first one because I want to actually do the first one. You ready? 3, 2, everyone, eyes on the screen. 3, 2, 1. Are they close? If you round to 2 digits, are they close? Yes, they are. If you stop here, what's this number? If you stop right here, what's this number? 7, 8. If you stop here, what's this number also? 7, 8. These. Why are they different though? By the way, which one is more accurate? The one that the calculator gave me, or the one that we measured? Which one had error in it for sure? The calculator or us? That Muhammad has. Muhammad is very confident in everyone's ability. Again, calculator. Which one is more accurate when it comes to calculation? Us or a machine? A machine. So no. Calculation. A machine. Because look how many numbers it could hold in its memory. Do you see what I mean? It's basically a small supercomputer. What's wrong with this one? Are you sure that those measurements were 100% exact? No way. Why do you think I made it 5.45? Because some of you said what? 5.5. And some of you said what? 5.4. So it depends on what? It depends on the person measuring. Do you see what I mean? So if at any moment, if you want to go with the more correct one, which one do you go with? Us or the machine? Yeah, the calculator, exactly. So, but do you see how correct they are? Okay, let's do the next one. Clear again. What is this one equal to? I mean, this was the sine. What is this one? Cosine. So I'm gonna do what? Same exact thing. By the way, just so you know, hold your cell phones. By the way, if you want to do this calculation on your cell phones, you cannot do it while the cell phone is what? Is vertical. Yeah, is like portrait. You have to do it what? Usually landscape, because it shows you all the what? All the functions, okay, or all the buttons. Here's the thing, everyone. Most of the time, your cell phone, you have to enter what first? You have to enter what? What do you have to give it first? The number, the angle, and then you tell it what? Think. Do I tell it what to do first, or do I tell the number first? So far, what am I doing first? Most machines, single display like this one, everyone, this one. The ones that you could borrow. These ones, everyone, look. These ones, you have to enter the number first, and then you tell it what to do with it. Okay? So I have to put the number first, and then go to trigonometry. Which one am I going to choose now? We're done the first one. Which one is the second one? Come on. The second one is what? Cosine. So you click cosine. We should get something very close to what? What's this number? Come on. 0.629. Okay. Here's the hope. If it's really, really different, I should not be teaching you math. 3, 2, 1. Hey, how many numbers agreed? The first what? The first two. It started with 6. It started with 6. It went to 2. It went to 2. What's the third number here? What's the third number here? But are they close enough? Perfect. Yes. Okay, show me again what you did. Oh, one more thing, everyone. Everyone, listen up. A very important source of mistakes for people is that listen up, Ryan. Okay, is that people have their calculators on something called RAD. You see RAD, right? Never have your calculator on what? RAD. RAD is just another way to report angles. Usually, how do you measure angles? In what unit? Come on. Degrees. But okay, hold on. In grade 12, if you ever take grade 12, like college or university, they will teach you another way to measure angles. It's called, again, Don't ask me why. It's just a different way, like centimeters and feet, and they will teach you something called radian. Do not ever have your calculator on what? RAD. Always have it in what mode? Capital D or like DEG, degree mode. If you have it on what? On, yeah, now you got the exact same one. You did get the right answer, but it was given to you in a what? In a different way. You see, it's like saying, how tall are you, Rauda? You could say, oh, Mr. Ramadan, I'm like 162 centimeters tall. Or you could tell me what? I'm 5'7". Do you see the difference? It's this. You are the same person, but you gave it to me in what? In two different ways. They are the same. I just have to understand how to go from one to the other. Okay? Okay, let's do the last one. What is my last one? I did my sine. I did my cosine. There's only one left. What's my last one? Come on. Sine, cosine, and tan. All right. Again, what do I have to put first? The tan or the number? I have to feed the number first. 51.5. We should get something very close to what? 1.239. We're ready? Let's see how close we got. Again, how close we get is on you because I didn't do the measurements. You did the measurement. You see what I mean? That's why we don't like to use measurements because they screw up things. 3, 2, 1, go. 1.2, 1.2. Instead of 3, I have what? I have 5. But are they close enough? Everyone, what does that tell you? Did I need to do measurements to find these numbers? Did I need to do measurements of sides to find these numbers? No. All I needed to measure, perfect, was just the what? The angle. If you measure the angle, it doesn't matter how big the triangle is. Yes. Perfect. Thank you. Everyone, how many people have double displays? Double display, because you can enter the whole thing and see it before you hit equal, you have to do what? You have to do the what? You have to do the opposite. You don't give it the number and then the what? And then the thing to do. No, you tell it what to do and then you give it the what? You give it the number as if you're physically writing it. What's the sine of 70 degrees? What's the tan of 7? Perfect. Yes. So always remember, knowing what kind of calculator you have could completely change your answer. Okay. By the way, I think most of you will end up having single display. So most of you will have to put the number first and then choose which one of those three, for example, this one. Okay? So everyone, listen to me. The whole point of this exercise is to tell you, as long as the triangle looks the same, everyone look, I'm going to make this triangle smaller. Oh, my bad. Everyone, check this out. Is it still the exact same shape? Which means if I met, but does that mean this is still, what was it? Is this still 51.5? Yes, hold on. The triangle got smaller, but did this angle change? Did it get bigger or smaller? No, it's still the same opening, which means what? The triangle is different, but guess what? If you measure the adjacent, if you measure the opposite, and if you measure the what? Come on, the hypotenuse, and you do your three ratios, guess what? You're gonna get the exact same things, even though the numbers here will be what? Smaller. That's the take-home message from today. As long as the angles stay the same, does the size of the triangle matter? As long as the angles stay the same, does the size of the triangle matter? No, you're right. Absolutely not. All that matters is that the angles stay the same. And then you never need what? You never need to use what? Protractors or rulers, because you can just use what? This has everything stored in it. By the way, imagine this. Everyone, check this out. Let's say I sketch this triangle. Sorry. Everyone, pencils down, pencils down. I'm just proving to you what we're doing today. Is this a right triangle? Is this a right triangle? Yes, to the best of my ability, it's a right triangle. Who would like to guess what this angle is? By the way, I don't think it's 45 degrees. It's less. So pick anything. Come on, come on. You want 30? Okay, by the way, technically we have it here. So let's make it 35, okay? No problem. Everyone, I'm going to say 35. Okay? I want to get, listen up, the sine of 35, the cosine of 35, and the tangent of 35. But I don't want to measure things. I don't want to hold a ruler and measure this. What can I just use? What can I use? Exactly, the 3 buttons on here. Guess what? Without doing any measurement, I can tell you right now that if you measure this guy, I have no idea what it is. I have no idea how long this one is. I have no idea how long this one is. And I have no idea how long this one is. But I can tell you for a fact, if you measure them and then you did these ratios, which obviously will be different, you will get the following decimal. There you go. You will get, let's clear and erase. What's my angle? Come on. What's my angle? 35. You enter 35. And then you go to trig. Let's say I want opposite over hypotenuse. The ratio of this guy over this guy. Which one of those 3 do I use? Sine. I know without measuring the sides. I know without measuring the sides that if I did measure the sides and divide it, I'm going to get 0.57335 and so on. Okay, what if I wanted adjacent over hypotenuse, like this one over this one? Which one of the 3 should I use? Cosine, yes. So I will get erase 35. Oh, my bad. Completely erase. 35, trig, cosine. I know that this guy divided by this guy will give me this decimal, 0.81915, blah, 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 whatever. Finally, what if I wanted to divide this one by this one? What do I use? What's the last one? Usually sine, then cosine, then tan. That's usually how it goes. So I'm going to erase and do 35 degrees and do trigonometry and hit 10. Yes, it will give me 0.700 if I bother to measure this one and this one. The powerful of today's lesson is that you will never have to measure a single time in your life, unless you want to check your answer. But if you just go do the math again and just make sure that your math is correct, it doesn't matter if the diagram does not look right, your math is correct. And that's the whole idea. Okay? All right. Last one for today. Okay. Everyone, to do this unit, you need what kind of a calculator? What makes a calculator actually scientific is the existence of which buttons? 3 buttons. Which ones? Ah, it's okay. It's okay. It's trust me. I've known people in college and university who still call it what? Who still call it sin. It's a sin to say sin. Never say sin. You say what? Even though it looks like sin. It has to have what buttons? Sine, cosine, and tan. If any calculator has everything except for those 3, I don't care how fancy it is. It is not called what? It's not called a what? It's not called scientific. Scientific calculators are only the ones with exactly these 3 special ones. Okay? That's why most cell phone ones are what? Scientific, because when you spend them, you see a lot of functions, but especially those 3. Okay? So, yeah, by the way, you cannot do these these fractions in your head. Okay? Look at, do you think I can do this in my head? Do you think I memorize the sine and the cosine and the tangent of every single angle from 0 to 90? No, but I know exactly how to use these things. Okay? So let's finally, okay, repeat this one. Okay, everyone. I made sure that when I sketch this one, it's 30 and 60. Can you actually check that, please? Go ahead. Check with the protractor that this is indeed the 30-60 triangle, which, by the way, is the famous one you can see in any geometry kit. By the way, everyone, the only 2 you can find in any geometry kit on the planet is either the what? The 30-60. What's the other one? Come on, 2 angles are the same. Come on. What are these 2 angles? 45 and 45. No other geometry kit manufacturer ever makes 20-70 or 51 and 39. It's either 45-45 or 30-60. Okay. Are they perfect? Okay, good. Because I was afraid when I printed them, it distorted it. Okay, go ahead, everyone. Go ahead and measure the 3 sides. Come on. Measure so the exercise we just did, I want to leave you with a note just like that. So go ahead, measure the length of the 3 sides with a ruler. And let's hear some answers. By the way, we're only going to do this page today. Tomorrow, we're going to do the second page. This lesson always has to span 2 days. Okay, let's hear some people. Oh, How many angles do I have showing? 3. But how many are we're always going to look at either this one or, by the way, do you ever look at the 90? But do you still need it to be there? Thank you. We just want to make sure it's there. I can choose this one or I can choose this one. Apparently, which one am I choosing? Which one? 30. By the way, I have a habit of always choosing the one on the ground. I have a habit. Other teachers might choose the top one. Doesn't matter. So go ahead, everyone. Circle this one. Just circle it like this. Okay. Who's got? Oh, can someone tell me where's the hypotenuse? Okay, so the hype is here. Where's the opposite to 30? Where's the opposite to 30? Is it this one? No. Yeah, good. Thank you. Opposite and adjacent. Okay, let's hear some numbers. Yes, Noor, what do you have? And which one? For the opposite? Noor got 3.4. Show of hands. 3.4. Okay, just one more hand, please. Can someone measure the opposite for us as well? 3. Lavania, did you say 3.4? Someone had their hand up. Or maybe Kareem? Did you say 3.4? No. Who agrees that? Oh, you. Okay. So everyone, we're going to go with 3.4. So go ahead. 3.4 centimeters. Okay. Who's got something else? Either hype or edge. I really don't care. Hala, what did you get? Sorry, Hala or Hala? Hala, yes. What did you get? I'm assuming for this guy. Okay, 7.8. All right. Again, if I don't hear any disagreement, I'm going to go with 7.8. Oh, 6 or 7? Yeah, it doesn't even make it to 7. So 6.8? Okay, 6 point. My bad. It's okay. No problem. You see why you don't measure? Because even we could be smart and still make that stupid mistake. What is the adjacent? No way 6.9. Why not? No, Amr, it's good. Why it can't be 6.9? Can you ever have a length longer than the hypotenuse? No way. What'd you get, Killen? 5 point. How many people got 5.9? Thank you. Okay, I see a lot of hands, so 5.9. All right. Awesome. So let's put the calculations here now. All right. Let me zoom out so you can see the triangle and the table. Okay. Opposite over hypotenuse. Well, according to this labeling, what's my opposite? 3.4. I'm going to go with green. 3.4 divided by 6.8. Wow. What's 3.4 divided by 6.8? It's exactly what? 0.5, which is interesting. If you hit on the calculator sine 30, it's also going to give you what? 0.5. What does that mean? You actually measured what? You measured very, very well because your numbers were perfectly matched with the calculator. Hey, that was a strike of luck. So go ahead, 0.5. And if you just did sine of 30 without even knowing, everyone, without even knowing what those sides were, check this out. Look, 30 sine. What did we get? 0.5. Nice. Oh, my bad. I have to change the layout as usual every time. My bad. 1 second. There we go. Change the layout. Now we're good. Oh, there we go. We said 0.5 as usual. 0.5. Okay. How about the what? How about the adjacent over the hypotenuse? Well, according to your measurement, sorry, 5.9 divided by, oh, no guesses, 6.8. Okay, what is that? I'm not sure what it is, but we'll see. 5.9 divided by 6.8. How much? 0.86. Let's go with 3 digits as usual. What would this be? 867 or 868? Nice. 868. Let's see how close you guys were measuring. Let's get the cosine of what? Of this. All right. clear everything to have it. Okay, so 30 degrees. Which one am I going to choose now? Cosine. We're ready? Let's see how close we get to this. Nice. 866. You got me what? 86 what? Which means what? Your measurement are what? Thumbs up. Your measurement were so accurate. So 866. Last one. Opposite over adjacent, which is 3.4 divided by 5.9. All right, I'm not sure what that is. 3.4 divided by 5.9. What would this be? 576 or 577? 576. The 2 does not touch it or doesn't affect it. So 576. Okay, last one. With the trig, clear. Okay, 30 degrees. Which one do we choose? We're done with this. We're done with this. On to this one. 3, 2, 1. 577. What does that tell you? Perfect. Yes, perfect measurement. You still had to do the measurements, but you came out, you know what? Very, very, very good. So 0.577. We could have got all of these without what? Without measuring what? Without measuring what? Opposite or hypotenuse or adjacent. I just needed to know the what? The what? Come on. You just need, see, from now on, all you need to what? Apply trigonometry is that you just need to know the what? The angle. Either this one or this one, depending on which one you want to choose. You never need to use a ruler or a Okay, you might say, okay, a ruler I get. I don't have to use it. How am I going to know the angle without using a what? Protractor. Okay, I'm talking about if I give you a question on the test. I will tell you what the what? I will tell you what the what? What the angle is. And then you will assume this is what angle I have to choose. I have to use. That's it. Everything else is correct. Okay? What if I don't give you an angle? Okay, you might want to what? Measure it, but you never measure anything else after. You never measure any length. Okay? So, everyone, just to summarize before we're done for the day. So, to summarize when to use each trig ratio, always refer to the following table. And please make sure you always have this handout with you on tests and quizzes, because that will tell you which one work with each situation. If you have a situation where you need to relate what? Come on. Need to relate what? Come on. Opposite and hypotenuse. Which one is absent then or not important? Adjacent. So if you want to relate these two and you don't care about this one, which one do you use? Sine. You do not use the other two because they are completely useless. What if you want to relate adjacent and what? Adjacent hypotenuse, and you don't care for the what? Opposite. So you only care for this one and this one. Which one do you choose to use? Cosine. Finally, what if you just want to relate opposite to adjacent, and for some reason you do not care about the what? Like you don't want to find it, or it's not given to you and it's not important, and you want to just relate these two? What do you use? Tan, or short for what? Tangent. Okay? So tomorrow we will do, oh, okay, everyone. The most important step in trigonometry is labeling your what? But more importantly, you have to label the what? Into what? Into what? Opposite, adjacent, and hypotenuse. By the way, did we label the heads once today? Did we call it capital A, capital B, capital C once? No, we only labeled what? Opposite, adjacent, and so when you do trigonometry, you do not have to say A, B, C, or X, Y, Z. But when you do similar triangles, do you have to do that? Yes, you do, just like the quiz. Okay, so similar triangles, you have to label the heads. Trigonometry, you only label the sides with short words. And that's all there is today.